All right, so we're on number 9, and we're looking at what we're calling a complete graph. So in this case, we're looking at the complete graph K5. So what that means is it has 5 vertices, and every edge is connected to every other edge. You can draw it if you want to. You would just draw out 5 lines, and you would just connect each point to each other point. Okay, so this is a really messy drawing, but we can see this is kind of what K5 looks like. All right, so we've got some formulas here. The degree of every vertex, the formula for that is n minus 1. So remember, for this problem, n is 5. So we're going to make that substitution right there. And so our answer would be 4. We can verify that pretty easily by looking at our graph and seeing that there's 4 lines coming off of each vertex. The number of edges would be n times n minus 1 over 2. So these are all in your notes. Everywhere I have an n, I'm going to replace it with a 5. So a 5 there and a 5 there. Make sure you do your order of operations. You do have to do your parentheses first. So I end up with 20 over 2, which gives me a total of 10 edges. Now Hamilton paths is a little bit harder. This is n factorial. So I'm going to replace the n with a 5. And remember, the factorial tells me that I start with that number and I go down one counting number each time until I get all the way down to 1. So this is the product of 5 times 4 times 3 times 2 times 1. And if you put that into your calculator, you get 120. Now Hamilton circuits is n minus 1 in parentheses factorial. So for this one, once again, we're going to replace n with 5. So there's our replacement here. We need to follow our order of operations, so we do our parentheses first. So we're going to have 4 factorial. So we start with 4 and go down each time, down one number. So 4 times 3 times 2 times 1, and that comes out to be 24.